So with that, I will get started here. So we have I have here with me George Turner from IU. As you have seen in his bio, among other things, he's been a long time in the HPC area, mainly in the system administration, building systems. So lately, his new incarnation has been as an enterprise architect. And we learn from George today and what he's been doing here at IU and how it might be relevant for some of the things we do, at least the concept side. I personally believe when I listened to his talk recently, I thought some of those are very much applicable to how we build science-specific gateways. Yeah, with that, George, please take it away.
Okay. Thanks, Suresh. This is a talk that we gave Tuesday of this week. The list of authors there were actually, it was a tag team type presentation. So I'm going to be picking up their parts of the discussion. So if I stutter and stammer and sort of sound like I don't know what I'm talking about, that's sort of partially true. What our talk about was at our statewide IT conference was about enterprise architecture. Indiana University, our IT organization, which we call University Information Technology Services, UITS, we've started implementing an enterprise architecture approach to developing projects. And right up front, let me say, if you want to know all the gory details or start researching the gory details, because there's a lot of them, just Google TOGAF online. That's TOGAF online. And it'll bring up this great big document on the Open Group's architectural foundations, tools and mechanisms for doing enterprise architecture. So enterprise architecture is more architecting the enterprise. If you think about it that way, then you get a better grasp of what it is we're trying to do and what it is we're doing. Usually the best people to be doing enterprise architectures are MBA types. I'm an astrophysicist by training, so some of this does not come easy. But after I sort of got into it, I started seeing that, as an astrophysicist, we essentially use mathematics to do modeling. And I always wondered why Indiana University had a business, a Bachelor of Science in Business. Why is this a science degree? And now that I've started doing it, they're using different language to do modeling of business process. So that's sort of what I'm talking about, going to be talking about today. One of the features that we try to achieve with enterprise architecture within our IT organization is what can we do to improve our efficiencies? What can we do to make our jobs easier? And how down the road things just sort of work out well. So that's going to be the goal about how do we go about increasing the usability of the work products that we create. So moving on. I guess that's sort of what I just talked about. On the right-hand side, you'll see a diagram which is called the ADM, the Architecture Development Method. I talk about this a little bit later on, but I'll talk about it. That's not the primary focus of what I'm going to talk about today. I'm going to talk about something called the Enterprise Continuum. A very simplistic analogy of what the Enterprise Continuum is that as IT workers, we all create things. Software developers, you create functions and objects and various different things. As a sys-admin, I developed methods and mechanisms for building supercomputers. I'll sort of give an example of that later on. But the Enterprise Continuum to me sort of seems like this giant toy box. And as all of these these people that produce IT artifacts, as we call them, they go into like this toy box, the Enterprise Continuum. And then later on, when we're going to do something, we go over to the toy box and we pull out the various different toys and maybe even stick them together. So I'll sort of drill down into this in another example that I'll get to later on. So there are many components to the TOGAF model for doing enterprise architecture. I cut 3 examples here besides the Enterprise Continuum, which I'm going to be talking about today. I've mentioned the Architectural Development Method, ADM. That was that graphic on the previous screen, which I'll talk about a little bit later on. Another important component of enterprise architecture is the standards information base. And I almost want to apologize. If you were an MBA, a lot of this lingo would probably make sense. Me as a sys-admin and a software development, this is not a language that comes easy to me. But essentially what the standards information base is essentially we've gone out to everybody in our IT organization at IU here and says, what is it that you do? What are the tools that you do? So from a sys-admin standpoint, I could say that, well, we use XSEDE for our cluster management systems, okay? We also use ACE on our Cray. And so these are sort of the standards that we would have a category called cluster management systems. And we would put these, we would list what these various different standards are in the SIB, the Standards Information Base. And we could have things that are, now I apologize for not remembering exact terms, but you have things that are standards. So like XSEDE and ACE are standards. We have things that are deprecated or no longer can use, like VAX cluster, for those old enough to remember that one. So, and then there might be up and coming standards, which I can't think of a good sysadmin, but maybe in the software development area, there might be new languages that you quite haven't, people, it's not a standard that everybody's using, but there are people out there playing with it. You can see some good, strong features to it, whereas maybe COBOL might be one of those that, do not use, okay? And then another important thing is technical debt. I want to step back one step here. One of the things that we're trying to achieve with enterprise architecture at Indiana University is that we're not supposed to have any operational responsibilities. We have what's called the Council of Enterprise Architects, and they've taken an architect from networks. I come from the research systems side. We have a storage architect. We have network architects, software architects, data architects. I think there's a couple other I don't remember right off the bat. But anyway, so we've created this Council of Enterprise Architects. And in theory, we have no day-to-day operational responsibilities. Our job is to be able to talk to everybody in this organization. IT here at Indiana University is split sort of down the middle. Within this one organization, we have both research computing, which most of the folks that you've interacted with are. But on the other side, we also have the enterprise. They're the people that take care of the student records. They actually run the most important computer on this campus or on this university, and that's the one that prints my paycheck. And sort of do all that, what you would typically think of as enterprise computing that any business would do. Stepping back into the slide here, the idea of technical debt is that we make decisions that we have some goals, something that we want to achieve, and we make decisions about to optimize to get to that solution. Say you're pushing an application out, you got a deadline, it's due this Friday, and you've got to get it out. But we'll skip the documentation. We'll do that later on. Okay, this is a form of technical debt. Okay, you're pushing something off to the side to achieve your goal that you know that down the road you're going to have to deal with it, and it's going to take time, manpower, whatever, to actually deal with this debt that you've come on with. Okay, so anyways, that's what I described there. So today's talk is about the Enterprise Continuum. And if I go back to my toy box analogy, this is like lifting the lid and looking into the toy box. This yellow box on the right side This is the Enterprise Continuum. I want to draw your attention to the orange and green boxes in the middle here. We have an architectural continuum and a solutions continuum. And probably 85% about what I'm going to talk about are going to be what ends up in the solutions continuum. As the name continuum implies, there's a gradual, you have your extreme endpoints where you have generic solutions on the left and specific solutions on the right, okay? And in the next couple of slides, I will say that there's 4 specific cases that we put things in. You got to keep in the mind, though, that it's actually a continuum. A little later on, I'll describe some specific solutions that are on the right side, but as they get adopted and start becoming standard, somebody will say, hey, I like what you've done there. It starts moving from the extreme right side and starts moving to the left and becomes more of what we call an industry standard. So this is that same picture. The orange band in the previous screen is the top row going across. These are architectures. The green at the bottom are the solutions that I was talking about. Again, this is described as 4 distinct solution building block classes. Keep in mind, this is actually a continuum. Okay, so maybe one concept to keep in mind with this is that on the right side, you've developed very specific organizational solutions or solution building blocks. I'm going to start using this term, solution building blocks. That's that sort of widget we all make as software developers. You write a chunk of code to do something. As a sys-admin, I write a script to manage the cluster, or I write some statistics script to gather statistics on running jobs on the cluster or something like that. So on the right-hand side, these are very specific things that are not very reusable. Solution building blocks on the left-hand side are very generic. Somewhere in the middle, say common solutions might be bash, okay? All the way over on the left, a foundational solution would be programming languages. So you can sort of see how you can develop a continuum from something very generic, something that is reusable, to something that's very specific. I have a square nail that can only be hit with a certain type of hammer or something, okay? So moving on, all this slide does is sort of reiterate what I just said. As you go from the bottom, from the organizational specific architectures, as you move up, you gain reusability, you become more standards compliant, you have more agility and resilience and things like that. So that's all we're saying with this slide. This is sort of this is from a hardware type of example. Again, we have the foundation, the very generic on the left, the organizational specific solutions on the right. On the left, you have something very generic like a network. And as you start moving across the continuum, you start getting into more granular solutions, InfiniBand Ethernet. Taking the Ethernet one across, you have various different standards like 802.3a. For those old enough to remember the old thin net where we used to take essentially cable and connect computers with, that's what that is. 802.3, that should be actually BA. That's our modern 10 and 40 gigabit standards. Okay, and so as I move over to an organizational specific building block, I want to use the 10 gigabit per second portion of this standard, and I'm going to have pink cables for my management network, and I'm going to have blue cables that have routable addresses that I can reach out onto the internet with. So again, sort of wrapping up the past 2 or 3 slides, what I've been talking about. If I get all the way over there on the right-hand side, that's the way I've implemented may not be the way somebody else will want to implement it. But as I start moving back over to more and more generic building blocks, these are solutions that people can start, other people can use in a reusable sense. Now, maybe another sysadmin in another organization has seen that you're actually using different colors for your internal management network versus your external routable addresses. I like that idea. Okay, so now I'm starting to move away from this idea of discrete building blocks into, well, now we're pulling this back into something that's an industry standard or something that's more reusable, okay? I say instead of just using pink and blue, I want to use different colors, okay? And this is the basis of what my talk is about today. How can we change what we're doing, or when we're building something, how can we need to keep in mind reusability down the road. So how can I change what it is I'm implementing here to achieve reusability down the road? And when I do that, I gain value down the road as I can take whatever solution I've created and I put it into my Enterprise Continuum as a solution that can be used down the road. Okay? So moving on. Now again, I'm sort of adapting a talk that we gave earlier this week. So what we're going to do is a little scenario to show some of the how some of these concepts come into play. And in this scenario, well, I'm going to let me step back just one second here. I've talked about the ADM, the Architectural Development Method. We use this when we engage in projects. So there are these various different phases. The preliminary phase is essentially just saying that we want to use our enterprise architecture techniques in this project that we're coming up, and some of the goals that we wish to achieve as an enterprise architect doing this. So I'm going to make a real quick run around the circle here. The architectural vision is sort of what's the vision of this project. As I said earlier on, this is sort of a business concept, enterprise architecture is. So you map out, one of the most important things you can do is why are we doing this? What are the business reasons for doing this project? You start looking at information systems. In TOGAF, this is actually split into two. You look at your applications and the data structures and how they are interrelated. You get around to D, which is the what type of hardware will this be running upon. Now, in the next slide, I'm going to collapse A through D into one slide. And then what's coming up, essentially the rest of my discussion is going to be about points E and F. Opportunities and solution is actually where you start designing what a lot of us would think is, well, this is where the real work starts getting done. As technologists, I suspect we're all sort of technologists. When we're told that we're going to be engaged in a program, the first thing we want to do is jump in and start, creating solutions. If you're a plumber and you say, I got a project I want to do, the first thing you want to do is grab a pipe wrench and a pipe and go at it, okay? So we tend to start in at the points D and E, and F is actually, the migration is actually starting to implement these projects, okay? So as technologists, we start coming in, we start thinking about doing a project here at the bottom of the circle. Going around, you got G, which is implementation governance as an enterprise architect. The work is actually to implement this project is already underway. This is more or less a bookkeeping phase. When you get to architectural change management, the project's pretty much done, and then so it's just a change management process. Maybe there's little tweaks. We don't really need to do much more enterprise architecture, or maybe as we're implementing this, going back to the technical debt. Maybe there were things that we couldn't implement in this first iteration, and we're going to have to go another iteration around this, okay? So we start a phase 2 on our project or something. So anyways, reiterating, I'm going to take it on the next slide, I'm going to collapse A through D into one slide. So as I move forward in this scenario, you'll understand what I'm talking about. So the various phases, A through D, are what's highlighted in blue here. We get together with the major stakeholders and look at the vision of what it is we want to do. We do the business architecture. Again, why are we doing this? We do the systems architecture, which is looking at your applications and your data structure, and we start making decisions about what technology we're going to use to implement everything we sort of develop. So, breezing through that, the scenario we have here is that the provost wants to set targets for improving student graduation rates. This is actually a real project here in Indiana. The governor and the legislature have set this out that universities need to improve these metrics. So I want to emphasize this is a hypothetical scenario. What I described here is not what real people are doing, but this is just a high-level view of how we're going to go about doing this, okay? And essentially as an example to explain what I'm building up to is the reusable building blocks, okay? For those of you who are old enough to remember the song about Alice's Restaurant, this is a song about Alice. So this is a song about building reusable solution building blocks, okay? So we need to create this new business capability. At Phase B, we decided that why we need to do this, and we saw that there was we did a gap analysis, and we saw that we were missing a piece. And we need some kind of student early warning system to identify students that are not making adequate progress towards graduating on time. So we go through. We identify some of the things that some of the requirements of this early warning systems. Class attendance could fit into this. What's their GPA trend? Financial aid status? Are they able to, meet the bills and things? What is their actual progress towards their degree? And actually, if we can go back and look at their high school records, that can give us some background on this student's ability to make progress. We probably, out of that list, we noticed that we identify class attendance as probably the most important feature of whether they're going to be able to graduate on time. So we decide that we need to come up with this, create this new business capability for determining class attendance. Some of the features of this project are sort of obvious. Authentication, we're going to have a development platform, web servers to interact with, database to keep the information on the back end, workflows for getting data in and getting the information out to the decision makers, document management, reporting tools. I mean, this is all sort of every project is going to need some of this stuff. So the continuum, and going back to the Enterprise Continuum, we built up this toy box or this toolbox called the Enterprise Continuum, and we've put in these solution building blocks into our Enterprise Continuum. So for authentication, we use CAS here. That's a very common solution building block that we use over and over again. The development platform is Java. We're a Java shop, they tell me. I'm a Fortran programmer. I don't think in Java. I don't know why they use Java, but they're the experts, not me. So again, some of these solution building blocks we're going to need. Web servers, Tomcat's something that's used very often. Again, so if you think back to the graphic where I had the Enterprise Continuum, where you had very generic items on the left-hand side and very specific things on the right-hand side, we're probably going down through that the third column there where we're naming Tomcat. I'm sure there's other web servers out there. I don't know what they are, but Tomcat is one that we reuse over and over again, okay? So database is Oracle, workflow, Quality Rice, document management, OnBase, reporting, Tableau, I believe is how you say that. So anyways, these are some of the, now they're going to go through and modify some of these, like the Tomcat configuration will be very specific for this program or project, okay? You may have access control list and things like that. So now you're pushing that solution building block farther to the right. The idea is as we come up with these building blocks and we stick them into the Enterprise Continuum, how can we want them to be reusable. So we go over to our Enterprise Continuum, we find the tools that we want, the solution building blocks, we modify them how we need them, and then they sort of push off to the right of that previous graphic. So I think this is just stating what more or less what I talked about. Identifying gaps, we sort of see what's missing. We go to our standards information base, and we see, well, there's something we don't have, say, a detector or something that we can put in the classroom that a student can come in and do, or we don't have a mechanism for doing the student attendance to class. So now we have to make a decision about, do we want to build something, buy something, or go a hybrid route? So what we're going to decide is that we want to create this new capability. How do we decide when a student is actually showing up for class? And we sort of start down this list again about what are some of the tools, what are some of the building blocks that we can use to implement a solution. This day and age, you can almost guarantee that students have some kind of smartphone with networking capabilities. Maybe it's Ethernet, maybe it's Bluetooth, maybe it's near field communication. Again, sort of thinking back to that Enterprise Continuum, I'm sort of going down somewhere about the middle of that continuum, somewhere maybe about the third column with these networking protocols. We're going to need some kind of device in the room that would detect the student actually being there, and this is going to be needed to be networked so that the data is actually delivered back to the database on the central computing systems. So at this point, this is going to be the core graph or slide of the talk, okay, as far as enterprise architecture goes. This is where the enterprise architect steps back and says, what other capabilities might I be able to use this for, okay? I have a very specific need. We're developing something, a solution building block that's over on the right-hand side of that continuum. What can I do? What features can I implement on this to actually pull this back to be something that's more reusable? What other places might I be able to reuse this capability? Well, we're detecting this capability that we're implementing is detecting the presence of a person, okay? This could be maybe manipulating door locks to get into the dorm. Maybe this is another use might be for this student is paid for meals and they're allowed to proceed into the cafeteria. Bookstore purchases or maybe parking. This individual is allowed to park because they have this token, their smartphone or whatever it is. So, okay. So if you'll think back to something I said very early on, as far as the enterprise architects here at IU, we are to not have any operational role. We are supposed to be able to go out and talk to everybody. So that this is how we develop this base of knowledge about what are other people doing around here. What other needs might they use? You know, I might be able to take this idea and go walk down to the hall somebody else and say, you know, we're starting to think about this. You know, you talked about other things. How could you use this capability? What features would you like to see? Okay, so the idea is getting in the habit of thinking about how can I take my work and keep it reusable. And what that's going to do down the road is that essentially I don't have to reinvent the wheel. As a sys-admin, somebody once actually said, you know, the idea of a successful sys-admin is the length of time between recreating the same solution. So that's essentially what enterprise architecture is about, is just stopping and thinking about, I'm creating a solution. Are there other ways that this can be implemented? Start from that, and then let me customize it with the pink cables and the blue cables, and I'll implement my solution. But I put something into the enterprise continuum that can be of value to other people. And I think when Suresh was standing in the back of the class, or this talk that we gave at statewide IT this week, that's probably where the light bulb went on. what you guys do, I'm an old, like I said, I'm a Fortran developer, but the idea is that when I create a chunk of software or create a software capability, I want to be able to use that. I don't want to have to reinvent that wheel again. So if I keep that in mind as I'm building these things, and also being able to keep track of it. I've written a lot of Fortran code, and I can't find it to save my soul. So I guess that's sort of another feature of enterprise architecture, is that you discipline yourself to take these very simple steps. I mean, it seems simple that, oh, that's so obvious, I do it all the time. But if you're like me, you don't really do it. I can't find these old codes. If you go back and think about the round diagram with all the circles, what enterprise architecture is, what that architectural development method is they've come up with a list of steps. And these are things that the very first phase A was architectural vision. When you're looking at the vision of this project, these are things you might want to keep in mind, okay? And these are certain documents that you might want to produce as you're thinking of this architectural vision. When you move into the business side of this, there are certain documents or certain artifacts, they call them in enterprise architecture. There are certain artifacts that you might want to produce to describe why you're doing this. Like certain things are obvious, like who are the stakeholders, okay? Who's going to be paying for this? Again, why are we doing this? Okay, and as you go all the way around that ADM cycle, there are just sort of recommended steps, certain things that you want to do, and it's just a way of keeping tracks of things. Something I said earlier, repeating myself, was as technologists, we have a tendency to jump right in and want to start digging that ditch. You know, it's like, I know how to dig a ditch. But there's a lot of things that need to go on beforehand that we don't think of. And essentially that's what this enterprise architecture is all about, is having the discipline to go through and do the things, the preliminary steps that need to be done to get you to the point where you're doing useful work, the work products that you're producing are reusable, and then actually when you get into the implementation phases, you've probably thought of most of the things that you need to be thinking about, and you don't end up with technical debt and saying, oh, we've got to push this off to the side, we've got to get this done, and we'll come back and do it later. So jumping back into our scenario here, so we have the requirements to collect class attendance. This is a new capability we're going to build, and we've decided that we're actually going to purchase a device that we're going to stick up in the room so that when the students walk in, they're capable of being registered, their attendance registered. This is just a very little, if the Enterprise Continuum were a gem, this is one little facet on the gem. This is the Enterprise Continuum, the network view of the Enterprise Continuum here at Indiana University. Just briefly describing the graphic here. If you go from left to right, you're going from inter-building to the data center to user devices to guest devices. If you go from top to bottom, this is going to be all collapsed into a pink layer on a following graphic, the network layer. Looking at this graphic, you can see that we've broken it out into the lower you go, the more closer you get to physical hardware, the higher up you are, you're in more abstract, the application layer. So this is an eye chart. Don't try to read it. If you want it, these slides will be available and you can look at it. Also, if you want to see what our enterprise architecture is here at IU, you can go to cea.iu.edu and there are links off to our wiki. This is a work in progress, so I won't say much more. Anyways, so back to our scenario here. We have a vendor who has a device. It's going to be plugged into the network. It'll use the smartphones to decide how they're who's here in the class today. and they're going to have to plug into the network. So a vendor can look at this and say, okay, these are the network protocols that I have to work with. My device can PoE is power over Ethernet, so I don't need a plug to plug into. I just plug my Cat5 cable in. I can power up my device. I can use IPv4, and I can use Cat6e cabling. Okay, so if you think about our Enterprise Continuum, we're getting over into that third column. These are pretty reusable solution building blocks. Okay, we're not quite to the point where it's got to be a pink cable to do it with. As I said earlier, I took that entire network Enterprise Continuum and I've collapsed it down into the pink layer here. Another thing, feature about enterprise architecture is that you, when you create these artifacts, that you get the amount of detail right. So when we were talking with hardware vendors, now we're going to plug in. That was at one level. Now I'm going to start talking about the software that's going to be the application that's going to take this data and produce useful information on the other side. As an applications developer, this is probably going to be very applicable to what you guys do. So moving on, the Enterprise Continuum, I almost beat this one to death. I'm describing solution building blocks that I have taken from my that are in my Enterprise Continuum. So I'm going to go from the bottom up here, network layer. These are some of the solution building blocks that we decided that we're going to use to solve this problem. Some of these are pretty obvious. You know, I'm going to have fiber channel for my networking my disk to the hardware. It's going to be IPv4 over the enterprise network to get data from the classrooms into the data center. People are on the outside, like students, are going to need to look at this, so they're going to have to come in through firewalls. Some of that, again, these are solution building blocks that these are all standards that we implement here at Indiana University. So nothing here is really new. Climbing up, oops, wrong direction. Climbing up through the stack here, and actually, this is a good point here. As an applications developer, a lot of these solutions have already been picked for me. I'm not really going to get involved until I maybe get up to the load distribution layer or maybe the middleware layer. But somebody has come up with these solutions, somebody smarter than me if I was an applications developer, as far as, you know, what type of hardware to get, what kind of operating system that I want to run on. Now I'm starting to get into areas where I might have an influence. Maybe I could pick between an Oracle database or a MySQL database. Okay, this is an enterprise application, and the enterprise apps developers here tend to favor Oracle. Oops, as I move on up, load distribution layer. How am I going to balance this over the VMs that I'm going to have running? Middleware layer. Okay, now I'm starting to get into the area where I'm going to have more influence, and I'm going to be the one picking out the solution building blocks that I want to implement. Again, I go over to the Enterprise Continuum that IU has. These are things that are in that. I've not yet started specifically customizing them to the point where they're not reusable by other people. But, you know, again, this is probably what's already going on. But within enterprise architecture, we're more or less creating a process or standardizing the process that we go through. Okay, and then once I get up to the top layer, I'm going to use Java for this. I need two-factor authentication, sort of some of the parameters that I need for this. Okay, so looking at this little stack of the colored layers on the right. This is what's going to be called a reference architecture, okay? So this also becomes one of the solution building blocks. I take solutions building blocks to create another solution building block, okay? I'm going to breeze through another example that we had here as a sys-admin. This one's for building a supercomputer. Again, there should have been this graphic for the applications building folks. It somehow got deleted in my rush to get here today. But anyways, for the applications development, at the bottom you'll see these 3 reference architecture. They had a Java J2EE reference architecture. They had a .NET reference architecture. They had a third one. I don't remember what it was. I'll call it
PHP, I think.
PHP. That's right. So okay, these are reference architectures where they have taken the solution building blocks and put them together, and they create a reference architecture so that the next time I need to do a project, I can sort of go over there. Well, I got this stack that's already built. I know it works. Okay. How do I have to modify it to do the specific things that I want to do? Okay, so I'm just going to breeze through building a supercomputer. I decide what networks I want underneath. I decide what hardware I'm going to be running on. I pick an operating system. Here we're building a Cray. Cluster management, I'm going to use the advanced cluster engine. I'm going to use Torque and Moab. Now, the applications layer in the top level is actually a researcher that logs into the system. Is going to be creating some type of supercomputer model. Okay, so they're going to need things like Bash for shells, and then they got to authenticate to log in. And then once you get to the top level, they need source code editors, compilers, linkers, loaders, debuggers, sort of those things. Okay. So actually, I got there it is. Yeah. So this is the point I described. These are the reference architectures for the applications. I'm getting ready to wrap up. What would this process have looked like if we hadn't used the Enterprise Continuum? You're going to say the project's going to get assigned to some manager, and the manager's going to turn around to the folks that they work with. And, okay, well, how are we going to do this? And you have a brainstorming session, and, well, we could do this. It sort of works well with that, and you sort of develop it. You invent the wheel, okay? And the whole point of the Enterprise Continuum is that you reuse the work that you've done before. You create these, or you keep in mind when you're creating solutions, I want to create something generic or reusable, and then I want to modify it to my specific needs. I want to mold it to my specific needs. So with that, at the end there, the very last thing, if you have any interest in what I've been talking about or the basis for what I've been talking about, Google TOGAF online and you'll get more information. I will apologize that it is in business speak. It is not in programmer speak or sys-admin speak or physicist speak. But anyways, I think that's my spiel. Questions?
Yes, thanks, George. I think many of things what you talked are very relevant. That's why I was requesting. So I think we have close to 10 minutes. So so please go on. Anyone, any questions or any thoughts, some reflections from what George was describing?
Yeah, I've got some questions.
Sure, can I go
on? Great talk, George. And really interesting on methodology approaches. So I'm just wondering how objective versus subjective decision-making is in this approach. For example, if you're deciding whether to include a component in your continuum, say you want to do Fortran for something instead of Java, how is the decision-making done for that? To create the component to whatever goes into that component, and then the decision making for including that into the continuum. And similarly, are there objective measurements for deciding how reusability is working? Like, do you go back and look at how this whole architecture is doing in terms of reusability of its components to sort of get a objective measurement of how well the approach is working?
I'll answer the second part first. I think the metric will be how these solution building blocks that we end up in our continuum, how often are they reusable? We are just starting down this road. We've only started working on the Enterprise Continuum earlier this year, so there's not a lot in there. But what we need, sort of tackling your first part of your question, how do you decide what gets in there? Well, it's not the architect's job necessarily to put things into the continuum. It's all the people out there creating these IT widgets. They know what widgets they need. So I think working with the enterprise architects, that a developer like Suresh could come and say, hey, I've got this device, or I'm creating this software entity. I need to, we want to funnel jobs from our gateway onto the certain supercomputer, and we need these certain specific things like authentication and talking with the resource manager and stuff. And so this is sort of the way I see it developing. And then as the enterprise architect, the objective person that sort of sends back and sort of knows what other things are going on in the organization, he can say, well, if we make this building block or this reference architecture this way, then it might be applicable to some other needs that I've heard about people. And then you can take and modify it and make it more specific as a solution for you. Did I touch on your both questions?
Yeah, definitely. I do have a follow-up question, though.
Sure.
So I'm coming more from software development and in an agile style. And in that sort of style of development, we do functional test components that we're developing, and that sort of gives us feedback on whether that component does what we think it's doing and what the interested party wants it to do. And I'm just wondering, in this approach, how are the components defined? Is it in a functional way where you can run something or you can test them to see that they're doing what they're supposed to do? Or is it more sort of a descriptive thing where it's a little more subjective and people sort of have a fixed sort of description of the component?
The way I understand the agile development mechanism is that you iterate quite often. You get feedback from the end customer, shall I say, the stakeholder that wants this capability. And so I think what you're doing is you're creating the reference architecture. So the agile development method is effective at creating workable reference architectures. Okay, and now where they come down as being on the specific continuum, whether they're generic or specific. I guess the idea is that you keep in mind that you want to build as close to generic as you can, but you have specific solutions that you need to achieve. So I don't know. I'm going to split hairs here or split answers here, bifurcate my answer, and say that the idea is that when you're building something, you keep in the back of your mind reusability. I can write this so that maybe it requires a pink cable to plug in it. But if I just write the code so that I take a generic input or something, then maybe it's something that's reusable. I don't feel like I've answered your question adequately, but there it is.
Maybe one clarification, and this will be the last, and I'll let someone else ask. What do these components look like? Like, does it include install scripts that actually would build the component for you, or is it more of a textual description and pointers to whatever version of that language or tool is out there?
These are more theoretical concepts. I think you're getting down to, as I've described earlier, I mean, there's network components to the Enterprise Architectural Continuum. There are software components. So I think it's from your perspective, I think it could be all the way down to the way you package it up. what would you need? If you went to the Enterprise Continuum, what would you want to pull out? If it was me as a developer, I'd want to be able to pull out the code with the make script and be able to implement that with as little effort as I could. Does that answer your question?
Yeah, that's exactly right. To me, I'd like the down and dirty, okay, here's how to do it, and here's some scripts to build it on this architecture. And then that would be the definition of a component. And I think that makes sense. Thanks, George. That was a great talk.
You're welcome.
Hey, this is Don at UCAR. I just had a follow-up question, is that we've all got our legacy software, and then we're talking about building new components. What are you seeing in terms of trajectory, in terms of software development methodologies? I mean, are you seeing a lot more agile, or are you seeing more waterfall continuing, or just what is your overall sense of that direction?
I have the luxury of actually talking to both the enterprise developers and the researchers. So I think that on the enterprise side, everybody's going with the agile mechanism. The individual professor sitting in his office with a couple of grad students, that's more the waterfall mechanism. I think sure. With the sort of like the gateway structure here that I'm familiar with what Suresh and Remainder are doing, I think agile sort of makes a lot of sense. Me as a former scientific programmer, I used to build robotic telescopes and deal with particle physics experiments. Okay, I can really understand how agile is really attractive. Instead of trying to build the giant monolithic Cadillac car, it's like, well, I can get the engine working right, and then I can get the brakes working right, and I don't have to get everything right, push it out the door, and then, well, somebody tells me what's wrong with it, okay? So me as a former software developer, I really like the agile, and I think it's going to catch on. I think even with the smaller research groups, it's just sort of a good way to go.
Thanks. Appreciate the perspective and also the nice talk.
You're welcome. You're welcome.
Yeah. Thanks, Don. And also, we're getting close to the top of the hour, but also on Kenneth's last point, I think one thing also I appreciated, in what George's group and the enterprise folks, there's a different talk, related, more of an experimental style one. Like what I've appreciated is the how to approach the DevOps, going from all the way from code repository to directly it gets deployed, and always pushing forward approach. So I think there, just getting into the concreteness from the theoretical concept, what I appreciated there is going all the way from Docker images to using tools like Ansible and so on, which once you basically that's all in the agile methodologies, of course, going quickly developing something, and then they'll get deployed as Docker containers, and then you have a suite of Docker containers ready to go on OpenStack, and then you pick what you want and then just plug in your pieces and get going. When all of this again is going with the new software development approach, but hopefully the legacy software components also can get wrapped up into that kind of a build. The VM was also in the direction, but I felt the VM was heavy, and then this Docker being a more lighter weight approach, I think it's getting more traction in that direction is what I'm saying.
George, I have a question related to risk mitigation. So how is Toggle or that type of architecture is helping to mitigate the risk? Like risk of these reusable components not working the way it should.
There's going back to the TOGAF method. There are, and again, it's sort of a recipe for at this phase. There are things you want to think about, and they identify in 3 or 4 specific cases or phases as you go around that diagram with the circles in it. These are certain risks that you need to think about at this phase. They actually, it's a business thing. They actually have a form that they would, if you write it down and sort of detail what are the details of that risk. And what this does is it forces you to think about them. Okay, so now I might not know the specific answer to the risk that you're inquiring about here, But by just asking these sort of simple questions, it forces you to think about them. Okay. Now I think the question you asked was that you build the specific component for what it is I want to do, and what risks are inherent in that if I want to make it reusable. And so what am I giving up by making it reusable? I think what I'm suggesting is that you take something that's reusable and mold it to your specific need. You're asking the question backwards, okay?
Yeah.
And I think maybe that's what part of this is that we just, as technologists, we look for the solution and we run with it because we know it works. But if we just put a little bit more thought about in it, we can create reusable infrastructure, okay? And it's just sort of, I'm going to make a complaint about modern society and how it just goes too fast, okay? And this is a mechanism or a way for us to stop and slow down and sort of think about the things that, yes, we got a deadline coming on, but this is a way of forcing us to stop and think about how can I benefit from this down the road, or how can somebody else benefit from it down the road. It's just, it's stopping to smell the roses as we rush down the path, so.
Yeah, thank you very much, George. A great talk, and then have this recorded, so I'll share this with everyone as well, so if others might want to catch up on this one as well. Greatly appreciated, putting together a good version in a short time.
Okay. If somebody wants to email me or call me to discuss this, my email address is turnerg@iu.edu. I don't think we had it actually written down on any of the documentation or anything, so
I'll write it on the slides on the slideshow
good.
when you had that.
Obviously, Suresh can plug you into me, and some of you probably have seen me around. So, anyways, thanks for your attention, and
yeah, thanks again, George, and have a good weekend, everyone. We'll catch up again next week.
Thanks. Bye-bye.
Goodbye.
Good weekend all.
Yeah.